Welcome back. Today we are watching another Kurzgesagt video. These guys are awesome. Loved the last one, Black Hole Star. It was amazing. If you haven't checked it out, go check it out. Also, let me know what I should react to next because I'm really loving these. But today we're going to be reacting to how to terraform Mars with lasers. Okay, let's just hop right on in. Make sure to check out the original video.
Mars is a disappointing hellhole lacking practically everything we need to stay alive. It looks like we'll only ever have small crews spend a miserable time hidden underground.
Yeah, Mars doesn't have a lot of those things that we need to live.
New world. But to solve the planet's problems, we first need to make it worse and turn it into oceans of lava with gigantic lasers. This isn't a far-fetched science fiction.
It's like when you clean your house, you have to make a big mess first, you know? It gets messier before it gets neater.
If humanity solves some of its pressing problems and ventures into space to expand into the solar system, this may not be that far off.
Okay, so I know it's really early for me to be pausing, but quick thought on this. Is it possible? Probably. Will we ever work together to do it? Probably not. So, you know, there's a huge difference between technologically possible and actually feasible to pull off. And I think that a lot of these things like terraforming Mars or terraforming Venus, they're definitely technologically possible, but we're never going to devote the time, the resources, or get along well enough to actually do these things, in my opinion. However, this is one of my opinions that I would love to be proven wrong on.
Okay, so how do we terraform Mars quickly? Well, it's complicated.
It's complicated. Good. It is complicated, I'm sure.
Mars is dry and has no...
These guys should make a video game.
Its atmosphere is too thin to breathe or protect us from radiation, giving you a high risk of cancer. So to turn it into a new home for humanity, we have to give it a proper atmosphere similar to Earth's. It should be made of 21% oxygen, 79% nitrogen, and a tiny bit of CO2 at an average temperature of 14 degrees Celsius.
So are those things on the planet already? Or do we have to haul them in?
And then the ground has to be weathered into...
Because there's a lot of ice on Mars, isn't there?
We need to install a biosphere on the surface and prevent it all from being undone by installing protective measures that can stand the test of time. It is difficult, but a big laser makes it a lot easier. Challenge 1, the atmosphere.
Space lasers make everything more interesting.
Oxygen-rich atmosphere and was home to vast oceans and rivers. It held onto it for several 100 million years before it got blown away. Ultraviolet rays broke down the atmospheric gases and then the oceans until they were swept away by solar wind. Today, Mars is a dry, barren wasteland. Luckily, a sizable portion of the water is frozen in deep reservoirs and in the polar ice caps enough to create a very shallow ocean.
So how cold is Mars actually?
Bound as minerals in the Martian rocks, like the oxygen in the iron oxides that give the planet its rust red color, as well as carbon dioxide.
Ah, that's really clever. Okay.
To free these gases, we need
so you're going to melt them.
Aha. Which occurs at temperatures as high as on the surface of the sun.
Ooh.
In short, we want
that's a lot of energy.
Of Mars. The best way to do that would be to put
we can't even get solar power to be efficient.
The most powerful laser today is the Eli NP, able to produce beams of 10 petawatts of power for a trillionth of a second.
It's a lot of power.
Mars, we need a laser twice as powerful that runs continuously. The easiest way is
to
use a solar-pumped laser that can be powered directly with sunlight.
How would you possibly build a laser of that scale with that much power that doesn't overheat and melt itself immediately? Be really interesting. I'm sure there's a lot of theories on it. It's just something that we haven't thrown enough money at.
Glass rods that absorb energy and release it as a laser beam. If we build an array of mirrors in space about 11 times the size of the United States, we can focus enough sunlight onto them to melt Mars.
Just a few of them.
Let's do it. As the lasers hit the surface, about 750 kilograms of oxygen and some carbon dioxide emerge from every cubic meter of rock melted. If we are efficient, our lasers only need to melt through the top 8 meters of the surface.
8 meters?
It would look terrifying. The skies would be shrouded in storms, while the ground would glow red-hot, crisscrossed by currents of lava. Tireless laser beams sweep over the landscape, leaving trails too bright.
We really would turn Mars into hell then. Doom would come true.
Cools quickly. a strange snow falls. The ashes from all
Awesome
the
video
elements
game,
that
by the way.
solidify as they cool down, like silicon and iron. Mars is still a cold planet at this point. A happy side effect of
Even
this
with lava
is that all the
on
water
its
in the polar
surface.
ice caps and even deep underground rises into the sky as hot steam, forming clouds that rain down over the entire planet. They would wash out the nastier gases from the atmosphere like chlorine and carry away harmful elements that accumulated on the surface. In
Chlorine's
the end,
not
they
good.
would form shallow oceans, saltier than on Earth. We might need to do an extra cleanup afterwards. It would take about 50 years of continuous...
Turn the lasers on again!
...oxygen atmosphere. We could use this opportunity to dig deeper in some places, to
And then we'll keep the
create
lasers there in
oceans
case the
or
settlers
and
misbehave.
spare some landmark features like Olympus Mons and Valles
I love it.
Marineris. We're not done though. The resulting atmosphere is nearly 100% oxygen and only 0.2.
That's gotta be extremely flammable.
And very flammable.
Very
To make it
flammable.
similar to Earth
How would
and
we?
a lot safer,
How would the heat from the lasers not ignite
which Mars is
the
sadly lacking.
atmosphere?
We have to import it. The ideal source is Titan, a large
Jeez.
moon of Saturn, covered in a thick atmosphere that's almost entirely nitrogen. We just have to move 3,000 trillion tons from the outer solar system to Mars. While that's not easy, it is doable. To process that much of Titan's atmosphere, we have to construct giant automated factories on its surface, powered by our lasers to suck in the atmosphere and compress it into a liquid.
I was going to say that we barely get things into space as it is. And that may be technically true, although one thing to note is that the rate of rockets going into space each year is kind of doing one of these right now. That's due in part, a large part, to the privatization of space. You know, you got companies like SpaceX and stuff just launching like crazy. And, you know, that could potentially cause a problem for us here and for the future of us being a spacefaring civilization. I'm pretty sure that they actually have a video on that. But yeah, I mean, in the grand scheme of things, we launch a tiny amount of rockets compared to what we would need for what they're talking about here. Although it sounds like they might be going in a direction that's not a rocket, so that's interesting. Can't wait to hear.
This gets pumped into bullet-shaped tanks, which a mass driver shoots all the way to the red planet, where they explode and mix with the oxygen.
An American made this video, didn't they?
Individual missions to Saturn
Build a giant gun for it!
Enough resources, it should
I'm
be
American,
able to
so I'm
complete
allowed
the
to
task
joke
within
about
2
that.
generations. Of course, it would be much more convenient to have nitrogen left over from terraforming Venus on the side.
I just don't see us cooperating for generations on any project.
So, about a century after
As humans, I just can't see it happening. I really hope I'm proven wrong, but
if the liberated CO2 isn't enough to warm it up to temperatures we can stand, we just add some super
as a species, we would last a lot longer if we started cooperating on those scales. There's really no excuse that Earth can't be basically a heaven for everybody, but human greed reigns supreme.
We need to fill it with life. Challenge 2, biosphere. Installing a biosphere on a new planet is very difficult. Unexpected interactions between species or sudden diseases can destabilize it to the point of collapse.
Can you imagine going through all this effort, generations, trillions of dollars, like lives spent of effort, and then the biosphere collapses and just fails? That would really suck.
Things go well, life in the oceans will thrive. Life on land is harder. Plants need nutrient-filled ground to sink their roots into.
And there's no nutrients in the soil, right?
Is the congealed remains of lava and ash. We could wait for thousands of years for water and wind to grind it down into finer sands, or try to do it manually. But we want to be quick, and we have a big laser.
Got a lot of big
On and
lasers.
off in rapid succession would cause the ground to quickly heat up and contract, which breaks it into smaller and smaller pieces. Add a bit of water, and you get a sort of dark mud. Into this mud, we can mix fungi and nitrogen-fixing bacteria.
But how would we
They're
do
able
that?
to
Where would we
absorb
get it from?
nitrogen and convert it into nitrate compounds to feed plants. The first plants we want to bring are native to volcanic islands on Earth, since they're perfectly suited to the laser-blasted Martian landscape.
But how are we going to get them
Eventually,
there?
the enriched mud becomes
That's
the
a
foundation for grasslands and
immense
forests.
challenge on its
Mars's
own.
lower gravity, trees can become very tall very fast. Their roots gather the nutrients they need and then dig deeper to turn more rocks into soil, forming a self-sustaining ecosystem.
Yeah.
At this point, we can slowly introduce more plant varieties, insects and animals. Not mosquitoes though. The new biosphere needs to be maintained
Screw
to
mosquitoes.
prevent it from falling out of balance. If plants grow too quickly and absorb too much carbon dioxide, the planet cools down too much. If key species die out, we could see populations collapse faster than they could recover. On Earth, other species would move in to fill the void, but our Martian biosphere is not as flexible. It takes hundreds,
Be a lot
if not
smaller.
thousands of years before Mars becomes a stable environment. But eventually, the planet will have the potential to sustain large.
This would be very cool, though.
With air, water, and food available, we can finally call Mars black, blue, and green our home.
It would greatly increase our survival chances as a species
Will it last, though?
if we could get to another planet.
Challenge 3, the long-term future. There is a problem we haven't addressed. Mars's core does not produce a...
Although knowing humans, we'd
so it
probably
doesn't
start
have
developing
protection from
space
solar radiation
weapons
or cosmic rays.
and
This
be at
becomes
war with each
dangerous for
other.
the long-term health of Martian populations. So, as a final step, we need an artificial magnetic field.
How do you do that?
It doesn't have to be huge like Earth's. It just needs to deflect the solar wind enough so that it doesn't touch Mars. The easiest way is to construct a magnetic umbrella far ahead of Mars that splashes the solar wind to the sides. A big
Are we gonna use
cylinder
lasers somehow?
powered by nuclear facilities is all it takes. It would orbit at the Mars-Sun L1 point, keeping it constantly in between the Sun and Mars and protect the new atmosphere. And that's it.
How do you build redundancy into that, though? I feel like
Hefty resources.
the consequences of that failing are pretty big, you know? You need to have more than one.
Shaped solely by us and for us. A first step towards our future among the stars. The first step that we can already take down here on Earth is learning more about the physics and biology needed for such a project. To help you with that, we've created a series of lessons to build your fundamental understanding of these topics. Made in collaboration with our friends at
Brilliant.org. Not sponsored here. Okay, so that was really cool. It's a very cool concept to think about. I truly believe that it's something that we as humans will probably never do. Once again, I really hope that I'm wrong, but I just don't see us working together and committing those types of resources over generations to pull off a project like this. It's just something that I just don't see it happening. It's really cool to think about, though. And the science that, you know, is being developed, maybe not directly for this, but for things like this, and the experiments being done to see if this is possible, they actually, a lot of them will have applications in other scenarios other than just terraforming Mars. So that technology can, you know, benefit mankind in other ways as well. So it's good to think about this stuff regardless. I do hope that I'm wrong, though, and maybe soon we will do something like this. Anyway, thanks for watching. I really appreciate it, and I hope that you have a wonderful day.